Hey everyone, I'm Kabur Kwasa. I'm with Ismail. We're going to present a video embedding powered large vision models for dental diseases in Uganda. So we're group 51, Kabur Conrad, and I'm with Ismail. Next slide. Next slide. As you can see, we're going to introduce it, the related works, problem statement, research, and all that. So let's just jump into it. We're going to start with the introduction. Next slide. So to introduce this project, oral diseases are something that's an uncommunicable disease, but it's worldwide. People don't really look into taking care of themselves because it's never been a priority because they don't know how bad their situation is. But here we're trying to create a solution where a user can get to know, okay, even though I'm okay, I can always check and make my life better. As you can see everywhere, everyone has yellow teeth, not white teeth. This is because people don't know how to take care of themselves. So you're going to give them a solution where they can know where they're lacking and how they can improve. So this is the background and introduction to the research. So we're going to use a model, a large vision model to detect the diseases using the training data. We're going to give the model, then the model is going to be at first hosted online because we don't know how big it's going to be. Then after we shall try to push it to edge devices like a smartphone. So we did we did a literature review, and I got two research papers that were really attached to what we are researching about. The first paper I was talking about detecting dental caries using smartphones, and here they used the CNN, which could detect dental caries, normal images, I mean X-ray images, and then give people feedback. But in our case, we can't use X-rays because we want to be giving it to people who don't have access to X-rays. So we want to use normal objects. Then the second paper was talking about notation of the abnormalities in the in someone's dentals basically. So here they would use the LVMs like clip to detect and anomalies and then identifies them in the teeth of the people. So these were that there were many, but these are the two that really caught my attention. Next slide. So the problem statement. So the problem statement is people don't know how. Okay, people know how to take care of themselves orally, but when something comes up, that's when they usually decide to go to the hospital. So here we're providing a solution where a normal user can test themselves once in a while to check where they're lacking and how they can improve. And also the solution can help general practitioners, health people to bridge the gap between the knowledge of dental health, and then when someone comes for consultancy, they don't need to be really good. They just use our technology in order to give patients feedback on how they can improve their dental health. So our input, you're going to have two inputs. The primary input is what the users are going to be inputting, which is a real-time video stream capturing the people's dentals. Then the second input is a training data. So good a data set of Kego that has like normal images, not X-ray images that show the different diseases. So the output is going to be a box that's drawn around the disease and then giving what disease it is and then maybe recommendation. So objective is to have a high mean accuracy precision of over 0.85 for the overall detection accuracy. Next slide. Next slide. So the objective is basically to bring the objective of this research is to be able to bring this tool closer to the local communities. If you're able to bring it to like an edge device, people in villages can access it and then basically make better dental health decisions. Basically, you start seeing white teeth. Then for the other one is to identify caries and gums earlier other than waiting when it's now expensive when you have to remove the teeth and then maybe buy another teeth, which will be expensive. So this is like early stage treatment type of thing where you can now take the disease early. And the third one is to always give visual feedback. So now if I'm a doctor and I give a patient visual feedback, they'll be able to know, okay, this is only, and then also will have more trust. And someone, you tell them I'm sick, then they go and they type things in the laptop and then they give you feedback. You don't trust that. But here we shall be giving patients confidence in their doctors when they use our. Next slide. There. Uh, the research outputs. So we're going to develop, we want to develop a lightweight detect multiple diseases in real time using the video, achieving a mean accuracy precision score of over 0.85. So we have tried to test, we have tried to build on top of YOLO 8 using some images we found, and we hope that we can deploy it fully online. At the moment, it's somehow semi-online. Okay, it's fully online where we can only deploy with the solution. It can be on someone's internet, then the mobile phone can be accessed later. So the architecture, next slide. Next slide. So the architecture is, so one inputs real time, then the real time is digested or it's processed by the YOLO inference engine. It's going to check the features using mainly a backbone of CNN, depending on how we develop the model at the moment. I think at the moment you're using CNN or ResNet. So then after it outputs boxes around where the queries or the issue is, and then that's put into the video directly. Next slide. So with the data set, we used a data set from Cargo because we tried to look for image data sets that were not X-ray, that were free online. We found it hard, so we had to now go in for data for Cargo data sets, even though it's not allowed. Please forgive. So for the dental, it basically has the features. It has caries, calculus, conjunctivitis, tooth discoloring, ulcers, and hypodensia. Those are the diseases, image diseases that we are having, so that the images are put in folders where those diseases belong, and then they are fully with full annotation and argumentation. So basically, here we're going to use supervised learning fully because everything has been labeled. Next slide. So now I'm going to call in Ismail to take on to the next part.
These are the classes. These are the images we got. We divided them into 3 classes. We had the training, the validation, and the testing data. So these ones are the different cases for tooth cases like calculus, then caries, and others. And these are the images for each class we had. Like, for example, the first class we had 991 for training, then for validation 175, then for tests 130. Then this is the data visualized in a pie chart format to show like the data we had for the different classes and the percentage of the data we had, the training images. And this one, it is also displaying the images we had. The blue is for the training, and the orange is for validation, and the green is for the test. So you can see we had a lot of data for the training, and more data for the validation than the data for the tests. Let's look at some sample images that were in each class for the diseases, tooth diseases that we got. You can see these are some images like for the calculus. This is the row for calculus. Then there is this other case, hypodementia. These are the images and many others there. So let's talk about the model details. As my colleague had already said, we are going to use a lightweight YOLO model. It's called a YOLO is a model that looks at the image only at once, unlike other models that look at the image consecutively, like more times. So the YOLO looks at the image once and then classifies that image. Then for the demonstration, we shall deploy this model to mobile devices and cameras and smartphones, though we haven't deployed this model to these devices. Then the conclusions, we were able to develop the lightweight model. We trained it, and and we tested it. And here are some limitations that we trained it basing on the cargo images, but not actually Ugandan images. So it may perform differently when it may come to Uganda, when it handles Ugandan images. Then we have not tested on the actual cameras, like the real cameras, like implementing it on the cameras. We were able to train this model on the images and what images we had, though we have not implemented it in the real device. Then it is also limited to those cases, the classes that we had. Though we know in dentistry there are other classes or issues that may be available. Then it is also based on visual symptoms. So things like when did this start? How has it been how has it been treating you? Is it aching or what? This model doesn't do that. It basically looks at the current visual appearance of the tooth or the mouth to give you the classification. Then in our future steps, what we are going to do next, we shall focus on building the mobile app, then deploying it to the internet, also deploying it onto the mobile devices and cameras in case we get one. So that's all for our presentation. Thank you. In case I have left anything, Conrad, you can add on.
I guess that's all. That's it for now. As you're going to submit, you'll find the Jupyter notebook and this presentation. Thank you for listening.